Today we're going to talk about 1.5 basic postulates in geometry. So in this unit we're going to go over just some of the language used in geometry, as well as two postulates and angles and types of angles. So first let's go over some of the language you'll see being used in geometry. So one of the basic units is a point. Okay. And we'll get into naming it later, but first I just wanted you to visualize this. So this is what we call a point. We use it to mark locations, and it does not have width, height, or length. I know as a dot it looks like it has some width, but it doesn't actually have width. Okay, so the most basic unit is a point. Now, what if we had 2 points, and what if we connected them? Well, this line right here, we call it a segment or a line segment, okay? And this line segment is bound by 2 endpoints. These are called endpoints. And we're saying they are bound by these points because they have to stop at these points and they can't continue on past these points. So this is a segment. It does not have any width or height, but it does have length, and you can measure it in different units. For example, I could say this is, pretend it's 5 centimeters, so that would have some length. Now, what if it did continue past their points, and it just continued on forever and ever, and it just continued into infinity? We would call this a line. It is now a line, and again, we can get into naming later, but I just wanted to show you. So this is a line, and it will continue on forever in both directions, okay? So what if it only continued on in one direction, right? So on one end, let's pretend this isn't here. On one end, it's bound to some endpoint, but on the other end, it continues on and on until infinity. Well, now this is called a ray. Okay, now let's get into naming some of these. So, again, a point is a basic unit of geometry. It marks locations and it has no width, length, or height. So we have a point here called point D, and we would name it point D. And Apex says that points would always be named with capital letters. It could be any letter, it would just be capital letters. So how would we name this point right here? Well, we would just say point L, and that's it. So now, next, segments. These are lines bound by 2 points, and it has length only. Remember, it's bound by these endpoints, and it cannot go past it. So we can name these in 2 different ways. We could say segment AB or BA. Now, why do we write it like this? Well, it's tedious to write segment AB, so just writing a line and the letters A and B is a lot more short. And again, there are 2 different ways to name this type of segment. We can go in this way, AB, or the other way, BA. And on Apex, they will ask you to name rays and segments. Sorry, not rays. They'll ask you to name segments in multiple different ways. So you have to be comfortable and able to name it in multiple ways. So let's quickly practice. How would we name this segment? Well, we would just say CD or DC. And something I want you to notice is that this is a straight line. It is just a straight line, okay? That is important as we move on to the next points. You'll see. So next is a midpoint. This is a point in the middle of a segment, okay? So this is called midpoint C. And you can think of this as midpoint, mid, middle. And you think of the middle, it's just perfectly in the middle, just it's symmetric, or it should be. So that means AC should be the same length as CB. And now we can get into our first postulate, or the segment addition postulate. So this states, if point C is between points A and B, then A plus C should equal, AC plus CB should equal AB, right? So we want to know, is point C in between A and B? Well, that's only true if segment AC, which is 3, plus segment CB, which is 5, has to equal segment AB, or segment BA, which is 8. And this is true. 3 plus 5 is 8 equals 8. Therefore, point C lies between points A and B. Let's look at another example. We want to know, is point C between points A and B? Well, just like our segment addition postulate says, segment AC is 7 plus segment CB, or segment BC, 4. Is it equal to segment AB? Segment AB, which is 9. We can see that it is not equal to each other, so that means point C is not between points A and B. And you can see it clearly here. It's all the way up here. It's not actually in between the points. Next, let's talk about rays. It has one endpoint and it continues forever in the other direction. And this is something you can't measure because it's going on and on forever, so you can't measure it. Remember segments, like this triangle? This segment, AC, it's bound by the endpoints, so you can measure it. And right here I'm saying it's 7, centimeters, and it's just a random number. So now let's get into naming rays. Now, naming rays, it's important. There's only one way to name this ray. So remember, for segments, for example, in this segment, we could say segment BA or segment AB. But for rays, you can only have one name. And what's special about this name? It starts with the endpoint. So the endpoint is B, and the point and the side with the A will continue on and on forever. And you can see that clearly with this arrow. It's a line with an arrow. Remember, the segment was just a line, and I said you should keep in mind that it's just a line. But for the ray, it's a line and an arrow. And this arrow indicates you're going on and on forever in just one direction, okay? So how would we name this ray? We would just name it CD. And this shows that C is our endpoint and D is the direction where we're going on and on forever. It is not correct to say this. That is not correct, okay? So you have to beware of this naming convention. Next, a line. A line extends forever in both directions and you cannot measure it. Again, if it's going on forever and ever to infinity, you cannot measure it. So for this, I would say it's similar to a segment, but it just goes on and on forever. And this would go on in both directions. So for this line, you would call it AB. And remember, when you name segments, it's a straight line. But for lines, you have arrows in both directions. Okay? And, I would think you could also name this line BA, just like how you can name segments AB, BA in both directions. So how would you name this line? Well, same thing. It would just be a line with 2 arrows on each side, CD or DC. Both are okay. Next, let's get into angles. So an angle is just a figure formed by 2 rays or 2 segments. And these 2 rays and segments share an endpoint, okay? So here's one ray. This is ray AC. And here's another ray, AB. And they share an endpoint, A, okay? So this is an angle formed by 2 rays, So let's look at an angle formed by two segments. So AB is a segment. See how we're bound by the endpoints. And AC is also a segment, and we're bound by endpoints. So two segments share an endpoint to make an angle. Okay, and notice how I'm trying to show that's the same angle, but wait, maybe the letters are wrong. Let me change this really quick. C, B, okay. So how would we label, or how do we name these angles? Remember, we had to name segments, rays, lines. We also have to name angles. So for this angle, we can do a tiny triangle and say angle A. Another way to name it is say angle CAB or BAC. CAB, BAC. And why am I underlining this A right here? It's because the middle letter should be the vertex. This right here is the vertex. Vertex. And how can you remember that? Well, if you look at the angle, it sort of forms a V, and vertex starts with V. So that's how you can remember it. So yeah, that is how you name angles. Now there are different types of angles, and we can label them as such. So the first one is a zero angle. Now I didn't learn this when I was your age, so it was hard for me to understand, but let me try to draw it for you. Remember, let's take this angle for example, this one up here. Remember I said an angle was made up of two rays or two segments? So let's take this angle that is made up of two rays, okay? And let's just erase this. Imagine we took this ray, or actually maybe I can do this. Let me see. Oh yeah, okay. Imagine we take this ray and we just sort of move it all the way down until it's on top, right? So imagine we start from here. We have an angle of 45, right? But now if we move this, we're just making it smaller and smaller. So it gets smaller than 45, and now let's say it's 10 degrees, now it's 5, and it's getting really, really close, and all of a sudden it's 0. So that's how I would imagine zero angle. And it's important to keep in mind it's a ray, okay? Now, straight angle. The reason why I just did that demonstration is because it can be confusing to confuse or to mix up zero angle and straight angle. So that demonstration I just did was to sort of help you differentiate zero and straight, okay? So notice how zero angle is a ray and a straight angle is a line. See, these arrows are indicating it's going on and on in both directions, right? This arrow indicates it's going on and on infinitely in this direction. This arrow indicates it's going on and on in this direction. This arrow indicates we're going on and on in this direction, okay? So zero angle would be a ray, straight angle is a line. And we say it's straight because it's obviously straight and it makes an angle of 180 degrees. No more, no less. It's 180. Next, right angle. So this right angle, it will always be indicated by a square. And right angles measure to be 90 degrees. And it won't be any more and it won't be any less. Okay? And acute and obtuse. Acute angles are angles that are smaller than 90 degrees, okay? So anywhere, if I were to, let's see, touch this line, as long as it's this angle, this angle, this angle, this angle, this angle, or this angle, or this angle, anything smaller than 90, it is automatically acute, okay? Now, obtuse is the opposite. Anything bigger than 90 is obtuse. So if I were to move it again, if it's past 90, either here, 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 or here, it would be obtuse, okay? Now, all these words I described, zero, straight, right, acute, and obtuse, these are words you describe for a single angle, okay? And later, we will get into some vocabulary where we are talking about pairs of angles. So these words for now, it's to describe a single angle, okay?